Hello again, back here with the first lesson of Unit 8, which is factoring with a equal to 1. Last unit we talked about a lot of this converting from factored to standard form, where we FOILed here and solved. So we had x squared minus 9x plus 2x minus 18, or x squared minus 7x minus 18. So we worked through this process of going from factored to standard. Now we got to look at how do we go backward. Again, standard form is very commonly used, and the questions we may get involve having to factor that to find zeros, or to find x-intercepts or whatever it may be, particularly for that question. So let's focus on here is factoring with a equal to 1. So just knowing how to factor, converting from the standard to the factored form, and then how to solve these quadratics, and figure out what the x value is that makes the quadratic equal 0, or x values are, perhaps. So in connecting the dots, looking at these graphs below, again, we can look at these x-intercepts on these graphs and know, for instance, that this first graph is x minus 1, x minus 3. And again, because we have the x-intercept at 1 and the x-intercept at 3, so if you put 1 and 3 into each of those, that would make the full quadratic equal 0. Again, looking at the second one here, we find those x-intercepts. It's at -4 and -2. So this would have to be x plus 4 and x plus 2. Again, because if that's -4, then that term is 0. Or if this is -2, then that term is 0, and so on. This third one, you can see the x-intercepts are at -4 and 0. So again, we have x plus 4. But then our second one here would really be x plus or minus 0. It doesn't really matter. We could just rewrite that as x plus 4 and x, and you commonly will see the x put out front like this. But when it's a 0 intercept, or intercepts at the origin like it did here, you can just write that as x if you wish. So what we're going to do here is, the last unit we looked at that factored form from a graph. We found those x-intercepts. We used that zero product property to solve for those x's, and then we wrote them as ordered pairs commonly. Now we're going to use this, again, this unit, we're going to use the factored form from the standard, and we'll still use this idea of the zero product property to get those x-intercepts. You can see this is written as a ordered pair there, but we'll generally write these just as x equals when whatever that value happens to be. So things we're going to see here is things like greatest common factor and distributive property. But then we'll also see the process of going from this sort of expanded form to this factored form, or the standard form to the factored form. And so here you can just see pulling out common terms, and we'll talk about this more really in the next lesson. But 15x squared plus 10x, these each have a 5x in them. You could divide both sides by both terms, by 5x, and that would give you a 3x plus 2 left in the parentheses and a 5x on the outside. So really you're looking at 5x equaling 0 and 3x plus 2 equaling 0. So this is another form of factoring here that doesn't necessarily involve the two kind of x plus or minus and x plus or minus that you may traditionally see. Second one here just had one term with the x, so we can't divide out an x, we can just divide out a 4, and you can see then the 4 comes to the outside, and what's left on the inside is an x minus 9. So we'll use a little bit of that, but again, more of that probably next lesson. So converting from standard to factor. So again, what we're going to focus on in this lesson is just when a is 1. So it'll just be terms where it's just x squared. But what we're really looking for is this right here. We want, when we write this, x minus p and x minus q, okay, what we want to find is two terms that multiply to be that c. So these last two terms will multiply to be that c value, and then they add to be that b value. So for instance, if you take the values 3 and -6, they multiply to be -18, and they add to be -3. So that would mean that B term would be the -3 there, and the C term would be the -18. So we'll look at that through this process. You've perhaps done a little bit of this in quadratic algebra, but we're going to be looking a lot at what multiplies to C and adds to B. When we do this, we're going to get x-intercepts and we'll ultimately get solutions. And so these are really the same process. Again, typically when we write an x-intercept, we'll write it as an ordered pair. When we write a solution, we're going to write it as x equals. And so we'll be looking at this process through some examples now. So looking at this first example, again, multiply to C, add to B. So what we need is we know that these are going to be x's because this first term is 1x squared. So just be going back to that idea of foiling, the first terms, x times x would be x squared. So that makes it nice because now we just have to look at what could these two values be that would multiply to 12, okay? Now we also need to add to 8. So if we look at factors of 12, we've got 1 and 12, we've got 2 and 6, we've got 3 and 4. So sometimes the negative values can mess with this a little bit, and when a ends up not being equal to 1, it will get a little more complicated at that point as well. But here, everything is in the positive. So what we're really looking for is which of these multiply. Is it option 1, option 2, or option 3 that multiplies to 12 but adds to 8? And we can see pretty clearly that it's going to be that 2 and 6. So that means this has to be a 2 and a 6. And again, it's plus for both because these are both going to be positive values. So when we FOIL here, if we were to take first is x squared, outside, oh, sorry, not that, outside here would be x and a positive 6, that'd be 6x. Inside would be 2 and an x, that'd be 2x. And last would be a 2 and a 6, so that'd be 12. And again, you combine those like terms, and there's your 6 plus 2 to get it to be equal to 8. So finally, we know that our answer here is going to be x plus 2, x plus 6, which means if we were to go one step further, we could solve this quadratic by saying that means x plus 2 equals 0 or x plus 6 equals 0. So x is either going to be -2 or x will be -6. And we'll talk about that more. Second one here. Again, it's still just 1x, so we know it's going to be x and x. Now what we also know is that the C term is a negative term. And again, the only way to get a negative term is to have a positive and a negative. So that means we know that one of these will be plus and one of these will be minus. Okay, so that gives us another little hint as we look at what is going to add up to 8. And again, to add up to 8, then we know it's going to be one positive value and one negative value. So it's not going to be like the last one where it was just the 6 and the 2 combined. So as we look at the 20, we have 1 and 20. Of course, there's no way to get from there to 8. We have 2 and 10. We have 4 and 5. Now again, think of this as one positive and one negative. So it's really here, if you were to make either one of these positive, naturally, since it ends up being a plus 8, we need the bigger number to be positive so that it stays at plus. And you can see here, as you've probably already noted, that the 2 and the 10 work in this case because a positive 10 and a -2 would add up to 8. But a positive 10 and a -2 would multiply to a -20. So again, if we were to FOIL this, we would get x squared on the first terms. Outside would be a -2x. Inside would be a plus 10x. And last would be a -20. And those middle terms would end up being plus 8. And so our solution here, if we were to solve, it would mean that x plus 10 has to equal 0 or x minus 2 has to equal 0. So x would either be -10 or x would be 2. Okay, so a couple more here. We see here that we need values that end up multiplying to be a positive number, but adding to be a negative number. And again, how do you do that? Well, A negative times a negative is a positive. So what that tells us is we know this is going to be x minus. And again, because it's that 1x squared, it's easy to throw those x's in first. And we just know that it has to be two negative values because they need to add up to be negative, but multiply to be positive. So again, for 3, the only factors of 3 are 1 and 3. So that gives us a -3 and a -1. And you can see there, first, outside, inside, last, there's your -4x in the middle. So again, I'm not writing the f of x's in here, but these are all f of x's to show that they're functions, quadratic functions. So we have x -3 and x -1. And again, now to solve this, we would put and set x -3 equal to 0 and add the 3. So we know that x equals 3 is one of our zeros. And then we'd set the x -1 equal to 0, add 1. And again, this is like we're finding the x-intercept again, but now we're just solving for what value for x would make the quadratic equal 0, as you can see from here to here, which could be an important characteristic of these functions as we move forward. For instance, when a projectile is in the air, when it hits the ground, the value would be 0, as being kind of the height at that point. Couple last ones here. You can see these are a little unusual because they do not have a C term. That C term is really just a +0 here. So we have to think about what multiplies to be 0. Well, the only way you get 0 through multiplication is if one of the terms is itself 0. So what that tells us is we really have an x and an x here because of that 1x squared for the first term. One of them is -0, or again, you could just write it as x. And so what's the second value? Well, the second value is whatever makes this -7. And so to add up to -7 here between the two terms, we would need, with one term being 0, that means the other term would have to be -7. Okay. Now again, as you FOIL it, might be a little clearer to see this now. Here, I'll change colors. X times x here is x squared. The outside is a -7x. The inside is technically -0x. And the last is +7. And again, we could have put +0 there as well. It doesn't matter. And if this were +0, it doesn't matter. That whole middle term, the x term, or the b then, is -7, just as we wanted it to be up in the original equation. So again, really, if there is no c term, it's really nice because you know one of them has to be 0, and the other one is just the value of b. Okay, so if that middle term were +80x, then one of these would be +80. If it were -62.5x, then this would have been -62.5. So really then, as we're solving this, it's x plus or -0 equals 0. So x equals 0 is one of them. And again, that's why we can just write it as x. We don't need to write the plus or -0 in there at all if we don't want to. You could not include that. So we would actually could write our function like this, if you would like. And then again, the second x here would be that x -7 equals 0. So we add the 7 to both sides. And that means x equals 7. So x equals 0 and x equals 7 would be the solving this quadratic. And finally, one more here. This is a little bit of a peek ahead. And the peek ahead here is the idea that we've got this little negative out front. And this little negative out front, obviously a is not equal to 1 here. So I'm just, again, teasing the idea of pulling out a factor. And what we can do here is actually pull out a -1, okay? And when we pull out a -1, that just changes the sign of all of these, okay? So what we're going to do is basically act like the -1 isn't there for now, okay? So at the very bottom, we know that this is going to start with a -1, and then it's going to be x and x. And again, now we need things that multiply to be positive, to multiply to be a positive 8, but add to be a negative 6. Okay, so again, the only way to have things add to be negative but multiply to be positive here is to be a negative times a negative. So this is x minus and x minus. Okay, again, that negative 1, once I went through this step here, now I'm basically just forgetting about it for now. Okay, so what if I look at the number 8? Again, it's 1 and 8, or it's 2 and 4. And again, I need both of them to be negative. And so negative 2 and negative 4 would do the trick for us. So those would be a minus 2 and a minus 4. Now again, to verify this, I can now distribute this like you saw back on that greatest common factor slide. And that would be negative x squared, excuse me, a negative x plus 2, and then an x minus 4. And if I were to FOIL from there, I have negative x squared. Moving on this. Okay, here I'll use a different color as well. So there's a negative x squared. Outside would be negative x times negative 4, so that's plus 4x. Inside would be plus 2x. And last would be minus 8. And again, now if I look at that and I were to combine those middle terms, you can see that the middle terms end up being plus 6, which is what we have there. So again, that negative, and again, this is kind of a preview of coming attractions, that negative seems to kind of goof things up right away. But if we pull it out, and again, by pulling that out of the parentheses here and moving it out to here, it just changed the sign. Instead of negative x squared, now that's positive x squared. Instead of plus 6x, that's now minus 6x. Instead of minus 8, that's plus 8. Because if I were to redistribute that negative 1, then it changes them all back. And that's exactly what we did here. I ended up distributing that negative 1 back in, and then FOILed, and I got right back to where we started. So again, to be clear here, our final answer is negative 1 out front, x minus 2, x minus 4. So then when I'm solving for the zeros, it's still x minus 2 equals 0 and x minus 4 equals 0. I'm again just leaving that negative 1 out of this completely. So our zeros here are x equals 2 and x equals 4. Thank you very much for listening. As always, if you have questions, please ask.